Today, we're going to bring our particle system to life by adding a lifetime parameter. Let's go! Alright, so we're in the middle of a series of videos on building a particle system. We started with a mesh that's a stack of cards like you see here. Then we made all of these cards face the camera with this billboard node. Next, we use this #33 node to generate random values for our particle system. And last week, we added this emitter dimension parameter so that we can spread the particles out to fill the space of the emitter, like this. If you haven't seen the other videos in the series yet, I'll link the playlist down in the description so you can catch up. We're going through the process of slowly building up our particle system. Today, we're going to create a particle lifetime so that our particles can spawn, follow a behavior over the length of their lifetime, and then die. I'm excited about this because after today, we'll have a real particle system. Going forward, we'll be adding more features, but today's video marks the point where the particle system is actually functioning. All right, so let's get started. First, we're going to open up our Blackboard here, and I'll add a parameter, and we're going to call this particle speed. Oh, and by the way, I'm showing this in Unity right now, but in just a minute, we're going to switch over, and I'll show you how to do it in Unreal as well. Okay, and we're going to give our particle speed parameter a default value of 1, and now we'll drag particle speed into our scene. Okay, so we're going to take our particle speed parameter here, and we're going to multiply it by time. So I'll just add a multiply node, and then I'll add a time node here and connect that up, and just kind of minimize everything down. So we'll take our time parameter, which is a value that just continually increments, and multiply it by speed. So this kind of controls the length of the particle's lifetime. All right, and we want each particle to be offset slightly, or so each particle has a different position in the phase of time. And so in order to achieve that, we can take the vertex color values that our particles have. What we have is our particle stack has each particle with a different grayscale value. So I'm accessing those values here with my vertex color node, and I'm splitting them so we're just taking the red channel. Now the vertex colors don't actually have color, they're just grayscale, so it's a gradient that goes from black to white. And so what I'm going to do is take each individual card that has a different grayscale value and add it to my time here. So I can just grab this red channel here and add it to time. And now what this does is each of the cards, it's going to have its own individual offset from time. So each of the cards will be in a slightly different position in the phase. And this is what I can use to create the particle's lifetime. So all I have to do now is add a frac value or a fraction node here. And this is going to take the time values that we've calculated and put them into a loop. And the result of this fraction node here is the particle's lifetime. So we're calculating the speed, adding in an offset, and then using this fraction, and now we have the lifetime. So in a previous video, we set up this lerp here, and we're lerping between the particle start size and the particle end size, but we didn't actually have a lifetime value yet. And so if I take the result of this fraction and plug it in where we needed the lifetime value, now what you can see is the particles actually living out their lives. And we can actually slow this down. So I'm going to set our particle speed value to something a little bit slower just for now. Let's set it to like 0.3. So each of these particles is going from the particle start size to the particle end size, and then popping back to the particle start size again. So you can see them kind of living out their lives and then looping back to the beginning. Now, this isn't exactly what we want because of that word looping. What we're getting is each of the particles is actually doing the same thing over and over. And so if you watch for a minute here, you'll see this repetitive pattern. So our yellow particles are growing up here and then spawning again and then growing up and then spawning again. And they're going to be the same for every lifetime that they live, which is not what we want. We want the particles to be more random. And so in order to fix that, we need to factor in our particles' lifetime in the random values that we're generating. So let's go ahead and do that. So we can take this and move it over. And okay, so this is our particle lifetime here. And if we take this value and just add it in to here, now what's going to happen is every time the particle spawns, it's going to generate different random values. So as soon as I plug this in, what you'll see here now is that each time the particle's spawning, we're getting different values. And the different values make the particles jump to a different position inside the emitter. And they also make the particles have different colors that we're seeing here. So if we watch this for a minute, you're never going to see the same pattern happening twice, because each time the particles start a new lifetime, they get a new random value. And then those random values are being used for the colors that we're outputting here, as well as the position offsets. So we're getting different results for each particle every time the particle's lifetime plays out. All right, so that's pretty cool. This is our particle lifetime here, this value coming out of the fraction. And we're using the time that we're creating to generate different random values each time the particle spawns. Now there is one more thing that we want to do. Right now our particles are just kind of smoothly going, and that's because our time is a constant value. But we also want to be able to control our time manually. And so I'm going to add two more parameters. I'm going to add a Boolean parameter. And this one we're going to call debug time. And I'm going to set it to false by default. And then the other parameter I'm going to add is a float. And this one is called manual time. And we're going to set it to be a slider. And the default value is going to be 0, and then it'll be from 0 to 1. Okay, so what we can do is create a branch node right here. And then we can blend using our debug time Boolean here. We can blend between manual time. If debug time is true, we're going to use manual time. And if debug time is false, then we're going to use our continuously flowing time. All right, and so what this allows us to do, just temporarily, instead of exposing this manual time parameter, I'm going to create a slider right here, and I'm going to show you what we can do with this. So I'm going to hook up our slider here into the true branch, and then I'm going to set our debug parameter here to true. And now what we have is a slider that controls time. So if I scroll, or if I slide the slider here, you can see our time advancing, and I can manually set time to anywhere I want between 0 and 1. And this can allow me to debug problems in the behavior of the particles, or if I want to manually control the time of my particle system with a script, for example, I could use a script that controls this exposed parameter and passes in the time values. So that's a pretty nice feature to have. All right, I'm going to set my debug time back to false so that time just goes continually. And I'm going to clean up the shader a little bit. I don't know if I mentioned this, but in between last week and this week, I did add these groups. So it's a little bit clearer to see where things are happening. I think I'll add a group here as well. And I'm going to call this one particle lifetime. We just want to keep things nice and organized. All right, there we go. So we'll go ahead and save our shader here. And I'm going to switch over to our scene. And we'll take a look at what we can do with these parameters. All right, so here's our particle system, and you can see our particles spawning and then dying. And I can change our emitter dimensions here. If we do something like 0.01, we can make our dimensions really small so that all our particles are in one specific location. You can also control the particle size, start size and end size. So I can start them out large and make them shrink down over their lifetime. Let's just spread these out a little bit so we can see what's happening. Okay, so now the particles are shrinking. I can also change the emitter so that, all of the particles are along one axis. So we have a really long particle system. I can make the particles start and end at the same size. And this way they don't change size, they just go from point 1 to point 1. And I can change their speed. So if I set this to 1 or 2, now you can see they're kind of blinking in and out quickly. You set this to something really big, we can get some interesting effects like that. So this particle speed, maybe this is named incorrectly, it's really influencing how long the particles live. The higher this value is, the longer the particles stay on screen before they respawn somewhere else. So if we set this to 0, you can see that they're just gonna stay alive forever and never die. But if we set this to something small, now they'll live their life slowly and then respawn in a slightly different location on the next lifetime. Okay, and then we can also set our debug time parameter here to true and then scroll the lifetime back and forth with our manual time. So we actually have a functioning particle system now. If I set this to 3, you can see we've got our little particles. Maybe we'll set the end size to 1 again. Turn off debug time. Now the particles are slowly growing over time. And again, we can control the length of time that it takes. Cool. So now we have an actual functioning particle system. However, one thing that I will say here is that our particles are actually kind of fixed in place. They can grow and shrink, and we can change the volume that they fill with the emitter dimensions, but they're not actually moving. They're not going from point A to point B. And that's what we're going to do next week. So next week I'm going to show you how to make the shader changes required to actually move the particles to a different position. Okay, so we have our particle billboards, so they're facing the camera. We're generating random values. We're creating our position offset, so the particles are filling the emitter dimensions. And today we added our particle lifetime so that the particles spawn, perform their behavior, and then die, and then respawn with a new random value. Pretty cool. Okay, let's switch over to Unreal, and I'll show you how to do the same thing there. All right, here we are in Unreal, and just like we did in Unity, we've been creating our particle system. We use this billboards node here to make all of our particles face the camera. We use the vector nodes here to generate random values for each of the particles, and that's what you can see that's generating all the different random colors for each of the cards. Now, I've said this in previous videos, but right now we're displaying these random values as colors on the cards, but eventually we're going to get to the point where we're not using these as colors anymore. We're going to use them as inputs for all kinds of things. The first thing that we're using them as inputs for is this position offset. So this is what we did last week. We created this emitter size parameter here that has an X, Y, and Z, and that's what controls how spread out or grouped closely together the particles are. Right now we've got our emitter size set to 300, but if I set this to something like 6, for example, now you can see that all of our cards are grouped really closely because our emitter size is just 6 centimeters cubed. So we had it set to 300, which is like 3 meters on all the dimensions, which gives our particles some room to spread out. And the way that they determine where they're going to be inside the emitter is based on these random color values that we're generating with our vector noise node. Okay, so we've got particles that face the camera and that have random values and that fill up this emitter size. And what we're going to do today, just like we did in Unity, is we're going to create a particle lifetime so that the particles can spawn and perform some kind of behavior and then die and respawn. And when they respawn, they're going to have different random values, so they'll respawn in different positions and have different behaviors. All right, so let's go ahead and get started with this. First thing that we need to do is create a particle speed parameter. So we're just going to call this particle speed, and I'll give it a default value of 1, and we're going to multiply this by time. There we go. And this particle speed parameter is kind of controlling how long the particles live. So the higher the value, the faster their lifetime will be, so the shorter they'll actually live. We multiplied that by time. And now we're going to add in the vertex color value that we're getting from each particle. So when I created the particle mesh here, each of the particles has its own unique value or grayscale color in a gradient between black and white. So if I take that value and add it to the time, now each of the particles is going to have its own unique position in the time phase. So instead of having all the particles move together in sync, each one is offset by the amount that I've created in this vertex color here. Okay, the last thing that we need to do is just take this value and add a frac node, which is going to make the time loop. Because right now the time is just like continuously getting higher and higher and higher. And if I add this frac node, what that's going to do is get rid of the whole number portion and just leave us with the decimal portion of the number. So no matter how high our time value gets, we're only going to go between 0 and 0.99999, and as soon as it gets up to 1, it's going to loop back to 0. That's what our fraction node does. And the result of this fraction node here is our particle lifetime. So right now, the one place where we need a particle lifetime is here. So here we're lerping between our particle start size and our particle end size, and we need an alpha value for the particle lifetime so that our particles start out this size and end up this size over the course of their life. So I'm going to take the result of this frac node here and plug it into our lerp to set up our particle lifetime. And now you can see our particles actually have a life. So as they go from the start size to the end size, you can see they're increasing in size here over and over. And I can switch this if I want them to get smaller over their lifetime. I can set the particle start size to something large and the particle end size to something small. And now instead of increasing in size over their lifetime, they're decreasing in size over their lifetime. Now, one issue that we have here is if we sit and watch this for a minute, you can see that each particle is spawning over and over and performing the exact same behavior. Like this particle right here, for example, it starts off in the same location, has the same color, and shrinks to the same size. It's just doing this over and over, and each one of them is doing that. And so there's just this continuous looping pattern of the same thing over and over. And we don't want that. We want the particles to be a bit more random than they are right now. And so what we're going to do is we're going to contribute some of this time that we're calculating here to the random values that we're calculating here. So I'm just going to spread these things out just a little bit to give us a little bit more space. And in our random values, I'm going to add a floor node here. And this is going to round down to the nearest whole number. And then after I add that floor number, or after I add that floor value, I'm also going to take this value here and we're going to floor it as well. So we're flooring time. And then I'm going to take the result of this and add it in. And what this is going to do is every time our particles spawn, they have a different time value that's happening here. And we're adding that value in before we generate our vector noise. And so each time the particles spawn, it's going to get a different color values here, different random values. And so each time it spawns, that value is going to be different, which means it's going to spawn in a different location within the emitter. And what this is going to do is it's going to change this up so that instead of repeating the same pattern over and over, each time the particle resets itself, it's going to jump to a different location. So I'm just going to go ahead and plug this into our vector noise node here. And now what you'll see is our colors are different every time. And the location where our particles start is different every time as well. So we get a little bit more randomness to the way that our particles are behaving. We never see the same color twice, and the particles never spawn in the same location twice either. So that gives us a little bit more varied behavior and a little bit more interesting pattern. So our particles are not looping like they were before. Now, if you did want them to loop for some reason, you could take out this add node here and just drag this directly in, and the particles would do the same behavior every time, the same thing over and over. But if you don't want that and you want them to do something kind of more random during each of their lifetimes, you can do it this way. All right, there is one more thing that I want to do here. Right now, we have a particle system that is a continuous particle system. It's continuously producing more particles, and their behavior and their movement is never ending. And that can be a good thing for some effects, but for other effects, like an explosion, for example, we want all the particles to spawn and that to be the end of it. And so what we're going to do is take our speed here, and this is the portion of the particle speed that is continuous because we're using our time parameter. But we also want to create another parameter that doesn't behave that way. And so I'm going to add another parameter in here, and we're going to call this one manual time. So instead of time progressing continuously, now we have a parameter where we can set time with a specific value. So we're going to blend between our continuously updating time and our manual time with another parameter here. And this one we're going to call debug time. And now we can control whether we're continuously progressing time or manually progressing time. So if I set debug time to a value of 1, now you can see our particles stopped moving because the time is controlled by this manual time value. And I can change this manual time value anywhere between 0 and 1 to manually control where on the timeline our particles are. And so if I wanted to, I could control this parameter with an external script or blueprint, for example, and just make time play once and then stop. And that way I could create an effect that just happened one time instead of like continuously going like they do with this portion of the branch. All right, so I'm going to set my debug time back to a default value of 0. And I'm going to set the min to 0 and the max to 1. All right, so now we have particles that are spawning and living and dying and respawning again, and we can switch back and forth between whether things progress continuously or if we want to manually change them like we're doing here. Okay, and just to keep things organized, I'm going to select all of these nodes and right click and pick create comment from selection. And this is going to be our lifetime. All right, so we've got things all nice and neat here. You can see that we've got our billboards, our position offset, our random values, and our lifetime. Let's go ahead and switch over to our scene, and we'll pull up a material instance here and see what we can do with these parameters. All right, here we are in our scene, and you can see that I've got my particle instance set up over here with all of the parameters that we've created so far. And I can change these things to affect the behavior of the particle system. So I'm going to set this particle speed to 0.2. Now you can see the particles are moving really slowly. And we can change the particle start size and end size. So if I set both of these to 0.1, now our particles start out small and they end up small. So they're not really changing at all. If we set our particle speed to 0, now the particles are not actually progressing in their lifetime. They're just staying the same. I can change the emitter size here. Let's set this to maybe shrink the emitter down really small. So now all our particles are clustered together in a 10 centimeter spot. And if I want to do something kind of interesting, I can spread these out. I can set one dimension of the emitter to be long. And now our particles are kind of clustered together in this little chain. So we can get all kinds of interesting effects. So our particles start out small and end up small, but I can make them a little bit larger. Now we have a nice chain of 1 meter particles. And if I want them to animate again, I can set their speed to 1. Now the particles are blinking in and out. As you can see, they spawn, live out their life, and then they die, and then spawn in a different location. So we have a lot of control over the particle system as it is right now. But the thing that I can see that's really obvious that we need to do next is to be able to make these particles actually move. Because right now they spawn, they can scale, they can grow and shrink, but they can't actually move from place to place. And so next week, in next week's tutorial, we're going to give our particles direction. We're going to be able to control where they move and how much they vary from that directional movement. And it's going to be cool. So hope you come back for that one. I hope you're enjoying this series on particle systems. Let me know what you'd like to see or what kind of features you think the particle system could use. I do have a plan for a lot of things that we're going to add in, but if you guys have some good ideas, I'd love to hear those. All right, we will see you next week, everybody. Thanks for watching.